This is lesson for 15-1. What we're starting today in this chapter is we are graphing piecewise functions. Now, it's been many months since we talked about what a piecewise function is. Back in September, we learned that a piecewise function is a group of functions that are graphed on the same coordinate plane, but only include certain intervals. All right, from here to here is this part of the graph, from here to here. Remember, the piecewise is the parts and pieces. All right, you have a bunch of different graphs that are sort of smushed together, but you only have a part of this graph and then a part of this graph. You're going to end up today with graphs that maybe go up like this, and then maybe go across like this, maybe go back up, or maybe they go down. All right, it's the different parts and pieces. You're also going to have some graphs where you might have a straight part of the graph, but then maybe you have a curved part of the graph. So it's the different parts and pieces. You're only doing graphs from like one x value to one x value, from one x value to the next is this, from one x value to the next is this, and then from one x value to the next is this. So you're going to have parts and pieces to our graphs. So what the questions look like are this. Remember, f of x just means y. All right, so we could type these right into your y equals. What you're doing in these graphs is you are going to graph y equals 2x plus 1 for all the x values that are less than 2. But then when it's 2 or greater, you're going to graph this graph. So because we have that overlap, we have to make sure that we are using open and closed dots. An open dot we're going to use whenever it says less than or greater than, because it doesn't include that number. We're going to use a closed dot or a filled in circle when it's or equal to. So when it's less than or equal to or greater than or equal to, because it does include the number. So if we take a look back at this example, the 2x plus 1 does not include the x equals 2 term, because that x equals 2 term is the equal to right here. So we would use an open dot for this one. We'd use a closed dot for the second one. When you go to graph it, there's no way to specifically graph the exact graph for each one. You can't do piecewise functions on the graphing calculators. You can only graph the entire thing, and then you just have to look at that one specific segment of the graph. All right. So when we take a look at, first of all, you're going to be asked not only to graph them, but you're going to be asked to find specific values. And you're going to be asked, is the graph a function or not? All right. The graph is a function if it passes the vertical line test. Now, again, it's been a while since we talked about the vertical line test. It's easier to say things that are not a function. All right. It is not a function. So the answer being no, it is not a function when there are 2 points directly above each other. All right, if there's 2 points that have the same x value, meaning that they're right directly above each other, so it fails the vertical line test, that's when it is not a function. So take a look at these that are not a function. See this purple vertical line? If you can draw a vertical line going straight up and down that goes through 2 dots at the same time, it is not a function. All right, it is not a function. So when there's 2 dots directly above each other, it's a no. Now you have to be careful, because is this not a function? Yes, it's not a function. All right. But you have this part doesn't include it, but this part does. But right next to it, all right, right next to it, I'm just going to switch colors here to maybe a green. Right next to it, you have a part here and a part here. All right, these are directly above each other. So because of this part, it is a no. But just be careful. Remember that open dot does not include that point, but everything that's right next to it. All right, looking at things that are a function. All right, I could take my vertical line and I could place it anywhere along this piecewise graph, and it's not going to cover up 2 points at the same time. Same thing here. Even this point right here, all right, I can draw a vertical line right there in the green, This doesn't include the dot. This does. That's where they match up. Let's just call that at x equals 1. So all along here, there's only 1 dot, 1 dot, 1 dot. Then we move up to here. There's still only 1 dot, 1 dot, 1 dot that I can cover up with a vertical line. So it's only a no when there's 2 dots directly above each other. All right. When there's 2 dots directly above each other, it's a no. Just be careful with the open dot and closed dot, because a closed dot does include the number, an open dot does not include the number. So let's take a look at what you're going to have to do today. This is what a typical question looks like today on your homework. You have to graph 2x plus 1 for all of the values that are x is less than 2. So again, less than, you're going to have an open dot. And then you're going to graph x squared plus 1 for all the values that are equal to 2 or greater than 2. So when we start graphing this one, we're going to start with a closed dot. So what I would suggest doing when you go to graph them is go to your y equals in the upper left-hand corner and type in this first equation. All right. When we type in this first equation, we have 2x plus 1. Remember, your x button is right next to the green button. So 2x plus 1. And we're going to graph it. We're going to graph it just to see what it looks like. All right. That's what our line looks like. But now we want only numbers that are less than 2. So take a look at this. All right. Over on my graph, hopefully you can see my cursor. We want all the numbers that are, if we go over to x equals 2 and go straight up, we want everything that is less than 2. So we want this part of the left-hand side of the graph. What are we doing with the right-hand part of the graph? It doesn't exist. All right. So all that we want are the numbers that are 2 or less. So I'm going to go to my table. All right. I'm going to go to my table and I'm going to move up on my table so I can see some negatives. And at 2, all right, at 2, now this is the sort of confusing part for a lot of people. At 2, I'm going to have an open dot. I'm not going to put a closed dot there because it's not or equal to. I'm going to put an open dot at 2 because that's where it ends. So 2 is 5. So over to 2 up to 5, I'm going to put an open dot right there. That means it includes like x equals 1.999999, but not 2. And then 1 is 3. So over to 1 up to 3. That's a point on the line. Over to 0 up to 1. That's a point on the line. Over to -1 down to -1. That's a point on the line. Over to -2 down to -3. That's a point on the line, and so on and so forth. So I'm going to connect these dots. And I need to put an arrow on the end of the line. And you should always label your line. On the Regents exam, they are very, very picky about you labeling lines. So that's that part of the graph. Notice that I don't have anything to the right of the graph because the right-hand part of the graph, and I'm just going to switch colors so you can see it better. The right-hand side part of the graph is this part of the graph. X squared plus 1. So I'm going to go back to my y equals. I'm going to clear out my equation. I'm going to type in x squared plus 1. And then I'm going to hit graph. So when you graph it, you get that U-shaped graph. But remember, we only want terms that are 2 or bigger. So I need to go back to my table. When I go back to my table, I need terms that are 2 or bigger. So I'm just going to ignore all these ones at the top. I'm going to go right to 2. 2 is 5, over to 2, up to 5. Now, what happens if they're the same dot like this one is? Well, if they're the same dot, you're going to color it in. All right. It's going to be a closed dot because the closed dot takes precedence over the open dot. All right. So we're going to see a closed dot there. And then 310 is our next one. Over to 3, up to 10. That's our next dot. Over to 4, up to 17. That's our next dot. And we can't fit anymore. So remember what this graph really looked like. This graph really looked like a U shape. So this was sort of towards the bottom of our U. So it doesn't form a straight line. It forms a U shape. So I'm going to make it look like a U shape like that. Make sure that you put your arrow on the end of your line. And we're going to label our line. F of x equals x squared plus 1. And that is a complete graph. Always make sure you have arrows on the ends. Now, when you go to answer these two questions, and you will have these on your homework today, f of -6. Well, this is really f of x. So we want to know where x is -6, where x is -6 is right here. And we want to go down to where our line is. Now, I didn't draw my graph far enough. So what I'm going to have to do is I'm going to have to go back to y equals. I'm going to have to type back in that other equation, unfortunately. And I'm going to go to my table, and my table will actually tell me this answer. -6 is -11. So if I actually extended my graph far enough over to -6 down to -11, I would have had a dot right there. F of 10. Now, f of 10 is way over here. That's obviously off my graph, but I need to use this blue equation. I need to use the second equation for x equals 10. So you have to make sure that you use the correct equation when you go to figure out your point. So back into my y equals, I typed in the correct equation. I'm going to go to second and table. I need to figure out what 10 is. So I need to go down on my chart here, all the way down to 10. So 10 is 101. And I can get that information right from the table. Just make sure that you're using the correct equation for the correct point. For example, if I accidentally use the red equation, that first equation for 10, I'm not going to get the right answer. All right. From x is greater than or equal to 2 and up, we're using that second equation. Is it a function? Yes or no? Are there two dots right directly above each other anywhere on this graph? No, there's not. Therefore, it is a function. All right. It passes the vertical line test because you can only cover up one dot at a time. Let's take a look at the second one. So on the second one, we have 2x plus 3, and that's when x is less than 0. And we have 3 minus x when x is greater than or equal to 0. So I'm going to go to my y equals. I'm going to type in that first equation, 2x plus 3. I'm going to hit graph just to make sure I see what it looks like. All right, that's what it looks like. For x is less than 0, it's going to be from the y-axis to the left of it. All right, all of these x values are less than 0. And this is where my open dot one is, and this is where my closed dot one is. Sometimes they're not right on top of each other like the first graph was. Sometimes they're spread apart. So I want to go to my table, second table, and I want all the numbers that are less than 0. You don't have to go crazy with your graph, all right? 0 is 3, so over 0 up to 3. And be careful, I almost just made a mistake. This is an open dot right here, all right? That's an open dot at 3. -1 and 1, so over to -1, up to +1. -2, -1. -3, -3. And -4, -5. So this is what my part of the graph looks like. I'm going to connect the dots. I'm going to put my arrow. I'm going to label my line. Now, for the second part of the graph, well, I'm going to do this part first. I'm sort of going to skip ahead. I can see that I have a -3 here. The -3 is less than 0, so I need to use this top equation. -3 is -3. Now I'm going to go to the second equation. So now I go back to my y equals. I want 3 minus x. I'm going to hit graph just to see what it looks like. So it looks like I'm going to have the right-hand side of the graph because I want all the numbers that are equal to 0 or bigger than 0. So I'm going to have this right-hand part of the graph that goes down like that. So I'm going to go to my table, second and table, and I want the numbers that are equal to 0. So I'm going to switch colors here just so you can see it a little bit better. At 0, it is 3. Remember, the closed dot supersedes or takes precedence over the open dot. So I'm going to make my open dot into a closed dot because they happen to be the same for this one. When x equals 0, y is 3. When f is 2, y is 1. So I'm going to answer those right away. And now we want all the numbers that are bigger than 0. So 1 is 2, over to 1, up to 2. 2 is 1, over to 2, up to 1. 3 is 0. 4 is -1. 5 is -2, and so on and so forth. Notice how I get this weird piecewise function that goes up until it reaches x equals 0 and then goes back down. All right, so we're going to label this. And is it a function or not a function? It is a function. All right, it passes the vertical line test. There are not 2 dots right directly above each other. If there were 2 dots right directly above each other, then it would be a no. So you're going to have some that only have 2 pieces. This one happens to have 3 pieces. You're going to do it the same exact way. So I'm going to go to my y equals, and I'm going to type in x plus 3. For x plus 3, it's going to look like that. So it's a line. I'm going to go to my table. I want all the numbers that are less than or equal to 0. So this is going to be a closed dot at 0 because of the or equal to. So at 0, it is 3. So I'm going to have a closed dot right there. I want all the numbers that are less than 0. So over to -1 up to 2, over to -2 up to +1, over to -3 up to 0, over to -4 down to -1. I can see what my line is going to look like now. I'm going to connect them. Well, that should be a straight line. All right, that wasn't very straight. Connect them and put your arrow on the end, label your line, and move on to the second one. So when we move on to the second part of this graph, we want the numbers that are in between 0 and equal to 2. So you're going to have an open dot here for the 0 because the less than. You're going to have a closed dot here for the 2. So when we go to do this, I'm going to skip ahead though. F of x equals -1. -1 is 2. I already graphed that part of the graph. So in between 0, all right, so I need f of x equals 3. So all this is equals to 3. There's no x to type in. So what does that graph really look like? Oh, it looks like a horizontal line. All right, it looks like a horizontal line right at 3. So when I go to my table, all of my y values are 3. That's because it's a horizontal line. So at 0, it is 3. That's where I left off. There's really an open dot, but there's really a closed dot already there. The closed dot takes precedence. So then I have 1. All right, 1 is also 3. And at 2, it's equal to 2. So this is a closed dot right here. So I'm going to connect the dots and I have my horizontal line right there. Now I just did x is 1. So over to 1 up to 3. And I can also tell it right from my table. 1 is 3. Then for the third part of the graph, we want 2x minus 1. So 2x minus 1. I'm going to hit my graph so I can see that I have another line that's going up. And I want all the numbers that are bigger than 2. Bigger than 2 is going to be an open dot at the 2. So I'm going to go to x equals 2 is 3. Well, this one happens to be right on that closed dot already. The closed dot takes precedence over the open dot. For 4, all right, or sorry, for 3, it's 5. So over to 3, up to 5. Over to 4, up to 7. And then I can't fit any more on my graph. So I'm just going to connect the dots. I end up with this piecewise function that looks like this. And I did forget to label this blue part of the graph. The blue part of the graph, f of x equals 3. Is it a function? Yes or no? Yes, it is. All right. Yes, it is. It will only be a no if there's 2 dots right directly above each other. So take a look at the next one here. All right. The next one, this one's sort of a weird one. All right. This one's sort of a weird one. And here's why. Notice that in our equations, we only want the numbers that are less than or equal to 2. Less than or equal to is going to be a closed dot. Less than or equal to -2. But then we want the numbers that are greater than 2. Well, what does it say about -1? What does it say about 0? What does it say about 1? It doesn't say anything about it. Well, if it doesn't say anything about it, there's just going to be a void, a blank space in the graph. So I'm going to go to my y equals, I'm going to type in 3x plus 5. I'm going to go to my table. Right? I want for 3x plus 5, I want all the numbers that are less than or equal to -2. So -2 is -1. Over to -2, down to -1. And because it's or equal to, that is a closed dot. And then -3 is -4. Over to -3, down to -4. Over to -4, down to -7. And my graph looks like this. So I have a straight line going like this, and this is f of x equals 3x plus 5. For the second part of my graph, I want to do x minus 4, and I want all the numbers that are greater than 2. So I'm going to go back to my y equals, type in x minus 4, but then this time I want all the numbers that are greater than 2. So that's going to be an open dot at the 2. So over to 2, up to -2, over to 2, down to -2. This is an open dot right there. For 3 is -1. 4 is 0. 5 is 1, and so on and so forth. So my graph over here looks like this. Notice that blank spot right in the middle. All right, we have that blank spot right in the middle because of our parameters. All right, in our parameters, we wanted all the numbers that are less than or equal to -2, but greater than +2. Not saying anything about -1, 0, or 1. So when you go to evaluate, we have f equals 2, or sorry, x equals 2. So when we have x equals 2, what is it at? Well, this one's sort of weird. All right, you'd be tempted to say that it's -2, but does it include +2 here? No, it starts off with like 2.00000001. We know nothing at all about the 2. When you know nothing at all about the number, you are going to write the words no solution. When you know nothing about it, because there's that blank spot in the graph, you're going to write no solution. Notice the same thing happens here for x equals 0. X equals 0 is also going to be no solution because we don't know anything about this middle part. Do we know anything about the -3? Yes, we do. We graphed -3 actually over to -3 down to -4. That's where the dot was, or we could have used the table. Is it a function? Yes, it is. All right. It's only not a function when there's 2 dots right directly above each other. Now, you might get, especially on the Regents exam, you might get some sort of word problem that you have to set up. This is the last example. It says a t-shirt print shop charges $8 per shirt plus a shipping charge of $10 for orders that are less than 20 shirts. If 20 or more shirts are ordered, then the charge is $7 per shirt and free shipping. So if we had to set this one up, all right, what we would be setting up is the following. This is a parts and pieces, a piecewise function. So $8 per shirt, $8 times the number of shirts plus the $10 for shipping. So 8x plus 10. When is that valid? All right, that is valid when there's orders of less than 20 shirts. So over here, I'm going to put X is less than 20. For the other part, when we order 20 or more, all right, it's $7 per shirt and free shipping. So $7 times the number of shirts plus free shipping. Technically, I could put a +0 there. I could just leave off the +0 because it is +0. But just in the context of the word problem, I'm just going to put the +0 there. And that is for anything that is 20 or more. So 20 or more is X is greater than or equal to 20. I know it's or equal to because it says 20 or more. If it just said more than 20, it'd just be greater than 20. So again, what you do is type these into your y equals. So we have 8x plus 10. Notice that on my graph, I don't have negatives. Why don't I have any negatives? Well, I don't have any negatives because I can't order a negative number of shirts. It doesn't make sense in the context of the problem. So if I order 0 shirts, I'm going to pay $10. Now that doesn't really make any sense. You're not going to order 0 shirts. You have to order something. So we're not even going to put a dot there. We're going to put our first dot at 1 and 18. All right, so our first dot is right approximately right there. Our second dot is 2 and 26. So that's going to be there. 3 and 34. So 3 and 34 is right about there. 4 and 42. All right, and we keep on going and keep on going. 5 and 50. Keep on going, keep on going, keep on going. I need to know what 20 is. So when we get to 20, 20 is 170. So over to 20, up to approximately where 170 is. And notice that at 170, this is going to be an open dot. So my line looks like that. All right. So how much will 15 t-shirts cost? I can see in my table right now, 15 are $130. For the numbers that are bigger or equal to 20, all right, I need the equation 7x. So second in table for 7x. For 20 exactly, it is 140, all right, which is right there. All right, for 20, it is 140. So that is right there, and that's a closed dot. So notice that you would actually be paying more for like 18 shirts than you would for 20 shirts because of the shipping. All right, just one of those things. All right. 30. Let's go figure out what 30 is. So 30 shirts would cost you 210. So over to 30, up to 210, which is right about there. And I can connect those dots just to make my life easier like that. And it keeps on going up in a straight line like that. So 30 is really 210. I can keep on going down on my table to figure out that 100 is $700. And this is what my line looks like. Is this a function? Yes, it is. All right. Even though it has 2 dots right above each other, remember one is a closed dot and one is an open dot.